Hello everyone, this is the final project I have for my neural network class. So this time for our final project is a project that has asked us to predict the temperature next hour based on the climate conditions and temperature over last 24 hours. And it is a multivariate and it's a time series forecasting problem. So actually, in our dataset, the professor gives us two different ones. The first one is the training dataset, which has 15 columns. So, but actually, we only have 14 different features, which gonna be our independent variables. So, I input my training dataset using pandas, and also I set the date time as the index instead of just being a variable in my dataset, since it's just the daytime. And as we talked before, we're gonna do the temperature prediction based on 24 hours. But we can see from the height of my training data, we have 14 different variables and the daytime. But at the beginning in the training dataset, the daytime is actually for each hours as one observations. We're gonna reshape our dataset to concrete each hours to be 24 hours, which is each day as per observations. And the T with degree centigrade will be our dependent variables, which be the target one, and all the others will be our independent variables. So in our dataset, after I set the index of as of my daytime, we have 14 different columns, which with 52,566 rows. So we also have the test set, but the test set is different. In the test set, we don't have headers, since the professor already gave us the final version of the test set. Each observations be each days, and it has 14 different variables as training dataset has. So each one, like each rows, have 336 columns. So the test set have 336 columns, and it has 17,447 rows. So before I'm doing any model build, I actually do the statistical descriptive to see, okay, so it's obviously we have 14 different numeric variables. So we want to count, okay, how many variables we have, how many observations we have, what's the average based on different variables, and what's their max numbers, and what's their mean numbers, and what's their average. So I did the same thing for my test dataset. So even though it doesn't really make sense because we don't have any headers, but still I want to see, okay, is there any difference? Since it share the same columns instead of just doing it without the headers. So for examples, the first one with the test set shows like how many count in the total data set. The mean is actually around 990, but for the training set is 980, so it's similar. So it's actually the same variables we have. And then I do a histogram to see all different variables we have in the training dataset. Since the training dataset is obviously it's easier to see differently. So our target variables is the T. So you can see this is actually fairly normal distributed, so it's really nice to be the dependent variables. So some of the variables are left skew, some of them are a little bit right skew, and you can see that WD variables is actually a double histogram. So and also since we have a numeric variable, so I do the correlation matrix to see how the variables related with our target variables, which is the T degree. So it's the temperature based on the degree C. So you can see that the variable RH and the variable RHO actually has the negative correlation with our target variable, and all the other is actually a positive one. Some of them may be relative negative, but overall looks really good. Then I'm start to build my model. So instead of just using the pandas, I'm doing the old-fashioned way. So I'm start to open my training set using open function and the test set using open function as well. So since it's a CSV file, we're gonna split each rows by the comma. Then I read every line in this and map them to be a list. Then since in our training dataset we have the header, so we do a copy as the header of it, and I do the dataset become of the second row since it's all the dataset we really need to build up the model. Then since even though it's all numeric, but when we read from the CSV it actually become a string, so I map every dataset I gonna use as a float in the end. And also since test sets already been reshaped correctly, but we have to reshape, or you can call it as binned data, to be nicer for our training dataset. So every 24 times, like 24 hours, we're gonna combine them to be the only like in the one column, one rows. So we're gonna have the same columns as the test set. Before we only have 14, now we're gonna have 336. Then I'm check the length of the bin data set, which is this, and it's correct to show as professor required. And I do the Y train. The train data set is actually our target variables, which is the temperature with degree C. Then I'm checking that, okay, the first entry for our train data set is gonna be the February 1st, 2009 at 1 o'clock, which is negative 4.44, and we get the correct result. And the first row, the first entry in our training data set is gonna become the January 1st, 2009, 100 until the February 1st, 2009 there, and I checked the result with the request, and I got correctly. Then I has to normalize our dataset. Instead of doing a z-score, I'm doing the min-max scalar. So I'm doing the min-max scalar for my x train set, x test set, and my y train set. So from here, you may notice that in our dataset, we don't have a validation dataset. So in the model part, I'm just using my x train and y train to build the model without the validation test. So I check the shape, and I check the shape for the y train and the y test as well. So we have three-dimensional correctly. Then I'm building the graph, building the model. Firstly, I'm using two layers. I'm using LSTM models, and I'm using activation model as a linear since we only have a time series problem, so I'm choosing the linear as my activation functions. Then I actually changed the optimizer to just become an item default one. I changed the learning rate, and I changed the L1 and L2 regularization numbers. Then the best number I get from the first model is around 0.01. And then I do try different one. I'm just building a very simple model. Then without doing a optimizer modification, I'm just using item as the previous one, and the best result I get is around 0.008. So that would be my final model. Thank you.